Now this is the last example from chapter 12.7. Now in this case we want to find the volume of the region enclosed by the sphere x squared plus y squared plus c squared equals to 1, and the cone c equals to square root of x squared plus y squared. Let's draw this domain. Okay. So we have a sphere. Okay, this is the sphere. Then let's draw the x, y, and z coordinate axes. X, y, and z. Okay, and now we have a cone. This is the cone. Okay. This cone will intersect with the sphere. And now in this problem, our goal is to find the volume of this spherical cap, this spherical cone, this part. Okay. Now we know that volume equals to triple integral of 1 dv over a domain E. Now in our case domain E is this one. Okay. Here we are going to use spherical coordinate system. Therefore triple integral of 1, in spherical coordinate system dv equals to rho squared sin phi d rho d theta d phi. Okay, let's figure out the limits. Now this is a sphere with radius 1. Okay, now rho is the radial distance. Rho is this distance. This is rho. Rho goes from 0 to 1 because the lower limit of rho should be 0, which is at the origin, and then we can go up to this sphere, which is 1. Okay, now theta is the angle on the xy plane, so theta should be this angle, and theta goes from 0 to 2 pi. Theta goes from 0 to 2 pi. And now we want to figure out the limits for the angle phi. Clearly the lower limit of phi should be 0. So this angle is phi. So this angle is phi. Now the maximum phi value is given by this angle. So this is phi max. And I think in this problem the tricky part is to figure out phi max. Okay. Now let's see how we can find the value of phi max. That's the maximum phi value. Okay. Now let's try to identify the equation of this circle, the intersection circle. At this intersection point, you have the same c coordinate, okay, and c coordinate of this cone is given by square root of x squared plus y squared, and the same c value lies on the sphere. So now what we need to do is we should replace c squared c with square root of x squared plus y squared. So we have c squared term this. Now if you simplify this, you will get x squared plus y squared plus another x squared plus y squared term. This is 2 times x squared plus y squared equals to 1. This means x squared plus y squared equals to 1/2. So in other words, if we look from the top, this line of intersection is a circle with radius 1 over root 2. So on the xy plane, you will see a circle with radius x squared plus y squared equals to 1 over 2. Therefore radius should be 1 over root 2. Okay, so now we need to use geometry. Actually we need to use simple trigonometric. Think about this right triangle. That right triangle. And as you can see, this distance equals to the radius of this sphere, which is 1. This is 1. So if you think about that right triangle, you will get something like this. This is 1, this distance is 1, this angle is phi max, and this length is the radius of this circle, which equals to 1 over root 2. Now we know that sine of phi max, sine of an angle equals to opposite over hypotenuse. So we have 1 over root 2, which is the length of the opposite side, over length of the hypotenuse should be 1. So here we have 1 over root 2 equals to sine of phi max. Now when is sine becomes 1 over root 2? When is sine becomes 1 over root 2? Well, the angle should be pi over 4. Okay, great. Now we have found the maximum value of angle phi. We can substitute that value over here. So this phi max should be pi over 4. Okay, let's integrate this. Integral of rho squared with respect to the rho variable is rho to the power 3 over 3. Lower limit is 0, upper limit is 1. And then we have d theta d phi sine phi term, and then the remaining two integrals. Okay, apply the upper limit, you will get 1 over 3, which is a constant. Then 0 to pi over 4, 0 to 2 pi, sine phi d theta d phi. Again, with respect to the theta variable, sine phi is a constant. So if you integrate this, you should get sine phi times theta apply the upper limit, you will get 2 pi minus the lower limit equals to 0. So you have 1/3 times 2 pi times the integral from 0 to pi over 4 of sine phi d phi. Integral of sine phi is minus cosine phi okay. So apply the upper limit first, you will get minus cosine phi cosine pi over 4 minus times minus cosine 0. Cosine pi over 4 is 1 over root 2. Minus times minus becomes plus. Cosine 0 is 1. The answer is 2 pi over 3 times 1 minus 1 over root 2. With this, we finished chapter 12.7, and as you can see, it is very easy to use spherical coordinate system to solve some specific triple integrals.